Hey, all right, we're going to be graphing inequalities. When we graph inequalities, you want to basically follow three quick steps. One, you want to put it into y equals mx plus b. That's our slope-intercept form to help us graph the line. Two, we're going to graph the line, and it's either going to be a solid line or a dotted line, depending on if it's equal to or not equal to as well. And then last, you want to shade. Greater than, you're going to be doing above the line, less than below the line, and we can use a test point to check if we wanted to. Let's go ahead and graph this inequality. Y is greater than 2x plus 1. All right, I'm going to start by graphing a normal line. Now, I know that my equation of a line is y equals mx plus b, so it's going to be the same idea here. So I'm going to give myself, all right, I see my y-intercept is at 1, so I'm going to go up 1 on the y-axis and give myself my first point there, and then my slope is 2, and remember, if there's no rise or run, so we can put a 1 underneath that 2, and we're going to go up 2 over 1, and that's going to give us our second point. Now these are the 2 points I can connect to give me my line. Now I notice up here this does not have an equal to sign underneath. Since there's not an equal to sign underneath the greater than, I'm just going to give myself a dotted line, and that means that those values are not included in the solution. Now, because we're greater than, we're going to be shading above the line. I think greater than is above, so all my solutions are going to be all these answers all above the line. Now, if we wanted to do a test point, we could pick any point on this whole graph and plug it in and see if it's true. So let's go ahead and take 0, 0. Let's take this point here, 0, 0. Now we don't have that shaded, so we shouldn't get a true answer when we check this. So let's plug this into our equation, our inequality up here. So my y value is, this is my xy, so my y is 0 is greater than 2 times x is 0 plus 1. This would give me 0 is greater than 1. Well, that's not true. That means I know my point is not included. So I know that this side, all down here, is not included because that's where I got my point 0, 0 from. So I know that we did it correctly. This is all not part of the solution. We don't want this included, but because the 0, 0 was not included, we did it all correctly and it's above the line, greater than.
Okay, let's do one more. Let's say we had y is less than or equal to negative 2x minus 1. Well, I'm just going to start by graphing my line like normal. So I've got a negative 1 for my b, my y-intercept. So we'll go down here to negative 1. And then I have a slope of negative 2 over 1. So I'll go down 1, 2, to the right 1, and I have my second point. And I have a equal to sign under the less than, so I'm going to draw a solid line, and because we are less than, I'm going to be shading below the line because we are less than. And if we wanted to check our work, we can again plug in a test point. 0, 0 is a good one to do because it's always it gives us nice numbers up here, easy to deal with. So if I plug 0 in for my x and y, I'll get 0 is less than or equal to negative 2 times 0 minus 1. That'll give me 0 is less than or equal to negative 1. This is false, so I know that 0, 0, that point 0, 0 is not included, which is not shaded here on my graph, so I know that we did it correctly. So here's my answer. Alright, let's say we didn't have one that was in a nice form that we wanted. It wasn't in y equals mx plus b. So first step, now we're just going to have to put it into y equals mx plus b. So if we had y equals mx plus b, okay, well, we need to solve for y, so let's go ahead and add 2/3 x to both sides. That's going to give us y is greater than 2/3 x plus 3. Now this is the line that we are going to want to graph. So let me put this up here, and I'm going to be graphing this line. Y is greater than 2/3 x plus 3. So I've got my intercept at plus 3, 1, 2, 3, and we've got our rise. Our slope here is 2/3, so our rise is 2, 1, 2, and our run is 1, 2, 3, and we've got another point here, and let me make my point in red, and we don't have an equal to sign this time, so it's going to be a dotted line, and we are greater than, so we're shading above. And I'm going to go ahead and pick a different test point here, because you don't have to pick 0, 0, you could pick any point, so I'm going to pick, let's pick 4, let's pick 0, 4 as our test point. So if we plug these values in to our original equation, we're going to get 4 is greater than 2/3 times 0 plus 3. That'll give us 4 is greater than 3, which is true. Now if I look over here on my graph to the point 0, 4, it will have 0, 1, 2, 3, 4. That point is right here, and it's included where I shaded. And this time, notice it's true instead. So I know that this area by that point should be shaded, which we have right there. So we got it. Alright, quick note, let's say we had a line x is greater than 3. Well, to graph x equals 3, remember we're on the x-axis over 3. Here we have a dotted line because it's not equal to. Now if we have a vertical line, it's we can't do above or below for greater than or less than. So what we do is, since we have a greater than is going to be to the right of the line, and think these are all positive. So instead of above and below, when we have a vertical line, you shade to the right for greater than, and then if we wanted less than, we would shade to the left.